Think about the features you expect in a car: comfortable seats, climate control, entertainment systems, and safety features like airbags and seatbelts. Heavy machinery, however, prioritizes function over comfort. Their design revolves around accomplishing specific tasks, often in challenging environments. A bulldozer, for example, needs raw power to move earth, while a crane requires stability and precision to lift and place heavy loads. Comfort features are minimal, with the operator's cabin designed for functionality and safety. Cars typically use internal combustion engines powered by gasoline or diesel fuel. These engines convert the chemical energy and fuel into mechanical energy, which propels the vehicle forward. These engines are designed for efficiency and a balance of power and fuel economy. Engineers work tirelessly to optimize the performance, ensuring that the engines run smoothly and reliably. Think about the different engine sizes in cars: smaller engines for fuel efficiency in city driving and larger engines for more power on highways. Each engine size is tailored to meet specific driving needs and conditions. Heavy machinery often utilizes much larger diesel engines, sometimes even multiple engines, to generate the massive torque and power required for their tasks. These engines are built to handle extreme loads and tough environments. Fuel efficiency is less of a concern than raw power output. The primary goal is to ensure that the machinery can perform its heavy-duty tasks without any hiccups. Imagine the force needed to move tons of earth or lift a shipping container. The engines in these machines are designed to provide that immense power. These engines are built for durability and longevity, often running for hours or even days at a time. Cars use transmissions to manage engine power delivery to the wheels, allowing for smooth acceleration and efficient cruising speeds. Most modern cars have automatic transmissions that shift gears seamlessly, while some sportier models offer manual transmissions for greater driver control. Heavy machinery requires specialized transmissions designed to handle immense torque and power output. These transmissions are often much larger and more robust than those found in cars, with multiple gears and specialized components for heavy-duty applications. Structural design differences. Cars prioritize a lightweight design for fuel efficiency and handling. This is crucial for modern vehicles as it not only improves performance but also reduces emissions, making them more environmentally friendly. They use a unibody construction, where the body and frame are integrated for a lighter and more rigid structure. This integration helps in enhancing the vehicle's overall safety and crashworthiness. Think about the materials used in cars: steel, aluminum, and even carbon fiber for lighter weight and increased fuel efficiency. These materials are chosen not just for their lightness but also for their strength and durability. Heavy machinery, on the other hand, demands extreme durability and stability. These machines are designed to perform under the most challenging conditions. They use a body-on-frame construction with a separate chassis supporting the heavy components and a body built for functionality rather than aesthetics. This design allows for easier repairs and modifications. These machines are built to withstand enormous stresses and impacts, using heavy-duty steel and reinforced components. This ensures they can handle the toughest jobs without compromising on performance. Their design prioritizes stability, ensuring they can operate safely on uneven terrain and under heavy loads. This stability is crucial for maintaining operational efficiency and safety on construction sites. Cars use a familiar steering wheel and pedal system for driver control. They incorporate numerous safety features like airbags, seatbelts, and electronic stability control to protect occupants in case of an accident. Heavy machinery often employs levers, joysticks, and hydraulic controls to operate various functions. Safety features focus on protecting the operator from the inherent risks of their tasks, such as rollover protection structures, object detection systems, and emergency shutdown mechanisms. Think about the unique challenges of operating heavy machinery: limited visibility, working at heights, and maneuvering in tight spaces. Safety systems are designed to mitigate these risks and ensure operator well-being.